It has been 3 short years. NASA began a journey to create the next space program, one that would take us beyond Earth orbit, returning us to the Moon, and extending our reach to Mars and beyond. No longer just a program on paper, Constellation has projects, hardware, and software in every stage of development. In just 3 years, Constellation is ready for its first test flights, launching a new era of human space exploration. Through the Constellation program, NASA has taken a vision, the idea of exploring beyond low Earth orbit, and strategically created a detailed space architecture, a plan to make the vision a reality. Constellation begins by conducting missions to the International Space Station, using the Space Laboratory as a destination and proving ground for a new generation of spacecraft. Next, Constellation sets its sights on the Moon, exploring the lunar surface in ways never before possible. Unlike Apollo, which was limited to the exploration of the lunar equator, Constellation's architecture will allow astronauts to explore anywhere on the Moon, staying twice as long as the Apollo missions, with twice as many crew members. This extended exploration capability has been a driving force for all of the Constellation spacecraft designs, which will be able to lift more mass and travel farther than any previous spacecraft. The Orion spacecraft is the crew exploration vehicle for Constellation. Orion borrows its shape and aerodynamic performance from Apollo, saving time and design work as well as reducing risk. However, the spacecraft is greater in size than Apollo, featuring updated computers, life support, electronics, heat protection, and other systems. The development of the Orion spacecraft is well underway. Several test articles have already been constructed and are being evaluated at NASA centers and engineering centers across the nation. Parachute drops have been conducted to test how Orion will return crews safely to Earth. The launch abort system, capable of pulling the spacecraft and its crew to safety in the event of an emergency, is set for a full-out test in 2009. While the rocket motors used in that system have already been evaluated in preparation for that flight test. The launch vehicle for Orion is called Ares 1. It features 2 key components utilizing legacy hardware. A solid rocket booster, similar to that used by the Space Shuttle, comprises the lower stage of Ares 1. The upper stage features a J2X liquid fuel rocket engine, derived from an Apollo-era rocket engine. Using these proven systems, the Ares 1 will get the crew into Earth orbit. The Ares 1 project completed its preliminary design review, the first such milestone in more than 35 years for a U.S. rocket. A test flight article of the Ares 1, called the Ares 1X, is slated for launch in 2009. The test flight will be a major turning point in the program, providing essential data on avionics, thrust vector control, and other systems, validating computer models by actually flying a full-scale vehicle. In preparation for the test flight, segments of the Ares 1X have already arrived at the Kennedy Space Center for assembly and processing. In addition, tests continue in all facets of the Ares program, from computer simulations to wind tunnel tests to engine test firings, providing engineers with the best information possible on how the crew launch vehicle will perform. Ares 5 is the heavy-lift cargo launch vehicle. It will carry the lunar lander and other large components into space. Again, using legacy hardware, the Ares 5 will utilize solid rocket boosters during liftoff to help get the vehicle into orbit. The crew on board the Orion will rendezvous with an Earth departure stage of Ares 5. The entire stack, Orion, the lunar lander, and the Earth departure stage, is then sent toward the Moon, once again using the J2X rocket motor. Because several key components of Ares 5 are the same as Ares 1, much of the engineering work being done applies to both vehicles, from solid rocket booster tests to firings of the J2X rocket engine, which is the first component to pass beyond the critical design review phase. In all, the Ares 5 will be able to lift more mass than any previous spacecraft. Studies have already been conducted to see how this versatile craft could be used to launch scientific payloads, satellites, and even space telescopes. The Altair lunar lander will carry 4 astronauts to the Moon. Larger and more robust than its Apollo predecessor, Altair will be able to land anywhere on the lunar surface, even the lunar poles, previously an unreachable target by manned spacecraft. The Constellation program recently completed a lunar capability concept review, demonstrating how the Altair lunar lander will reach the Moon and later help build lunar outposts. Spatial studies by engineers have helped determine the interior layout of the lander, driving out better ergonomic designs for the crews who must live on board for extended stays on the Moon. Additionally, work has already started on testing and improving all the gear needed for exploration in the Constellation era. From lunar rover tests to planetary spacesuits to tools, NASA is taking hardware out of the laboratory and into the field to achieve the best possible designs. In addition to the hardware development, NASA facilities are updating their capabilities for Constellation. New launch pads, lightning safety systems, firing rooms, factories, and testing facilities are being completed to accommodate the new wave of exploration requirements. Most importantly, the Constellation program is about people. From around the nation, all NASA centers are engaged in this new exploration effort. Problem solving, building, testing, and taking on the challenges of human space exploration. It is an effort that brings together generations, those who experienced the Apollo moon landings and those who came after. Together, they are working on a brighter future, looking to return to the Moon and go beyond. As the Constellation program leaps off the drawing table and onto the launch pad, a new chapter in exploration history is being written, one milestone at a time.